This video shows you how to do a chi-square test for two categorical variables in JMP, and I'm going to show it with a flash data set. So I'm going to analyze these two variables. The first one is sex, male or female, has two categories. The second one is peanut butter consumption. And that was categorized as once a day, twice a day, 3 times a day, once or twice a week, 3 to 4 times a week, 5 to 6 times a week, 1 to 3 times last month, or never, which is a total of 8 categories. So I'm going to be doing the chi-square test for 2 by 8 tables, which is a natural extension of the chi-square test for 2 by 2 tables that you learned in class. And what I'm going to show you, it's going to work for any number of categories. So when you have more than 2 categories in at least one of your 2 variables, you want to write your hypotheses out in words only. Don't write them out in conditional probabilities. It would be way too complicated. So just write them out in words. The null will be that the 2 variables are independent. So in this case, sex and peanut butter eating habits are independent. And the alternative will be that they are dependent. So I'm going to show you how to do this in JMP, where I've opened up the flash data set. I'm going to go to Analyze Fit Y by X. And then my explanatory variable is sex, because I'm trying to explain peanut butter eating habits by sex. And then my response variable is peanut butter. So I'll drag that to the Y response box. And then I'll click OK. So JMP produces a mosaic plot by default. So it shows you the distribution of peanut butter eating habits for females and also for males. It also produces this contingency table with way more information than you would ever want to put in your report, because it would completely overwhelm your reader. So it's showing the count for each cell. So there were 9 females that ate peanut butter once a day. It's also showing you the total percent, the column percent, and the row percent. So you definitely want to remove at least some of those. The total percent is the percent out of the grand total. The column percents add to 100 across the columns, and the row percents add to 100 across the rows. So I'm removing 2 of those. I'm left with my counts and my row percents. So what I can see here is that there were 9 females who ate peanut butter once a day, and there were 5 males. And that works out to be 7.44% of females in the study and 3.88% of males. So you can compare them this way. You can also get your expected values from this on the table. So you wouldn't want to leave it like this, because the reader's not going to know. I mean, you can kind of figure out from this key here where the expected are, but it'd be better to produce a separate table. This is the table of expected values, so it's just very clear. And then down at the bottom is your chi-square test statistic. It's the Pearson one, and the p-value is given right next to it. So that's how you can do a chi-square test for contingency tables in JMP when you have just more than just 2 by 2.